All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving this inequality question. All right, so this is okay. If today is your first day of watching our video, please subscribe. Now, to solve this question, we have that x squared plus 2x minus 3 is greater than or equal to 0. If you factorize this place, I'm going to have x squared plus 3x minus x minus 3 is greater than or equal to 0. So I have x into x plus 3, then x plus 3 here, okay, then minus 1 is greater than or equal to 0. So having that x plus 3 and x minus 1 is greater than or equal to 0. Now, from this place, you need to get the critical point. How do you get the critical point? Just say that x plus 3 is equal to 0 to show that x is equal to minus 3. Minus 3 is one of the critical points. Then here, x minus 1 is equal to 0 to show that x is equal to what? 1. So the two critical points I'm having is what? Minus 3 and 1. Then I have 0 in the middle here. Okay, so we need to check these three points. The 3 points we are checking is what? The 3 points we are checking is what? Inside this place, here and here. So I'm having that here is negative infinity and here is infinity itself. Now, if you have if you have equal to, any point you are using here must be closed. Okay, any point you are using at this particular place must be closed. So let us check for this side. Okay, we are checking. You are checking. So what are we checking? Now, for this side is that anything that is what? That is less than minus 3. So is there any number that is less than minus 3? You can check. Just pick any number you like. Minus 4 is less than minus 3. So let me check for minus 4. I'm having that x plus 3 and x minus 1 is greater than or equal to 0. So let me check for minus 4. So minus 4 plus 3 into minus 4 minus 1 is it greater than or equal to 0? Greater than 0 means that it is positive. So let's check if these two things will give me a positive number. This and this is giving minus 1 and this is giving minus 5. So the product of these two things is positive. So I'm having positive here. Okay, so let's check the middle between minus 3 and 1. Do you have any number that is between minus 3 and 1? Pick any number. For me, I want to pick 0. If I pick 0, I'm having that x plus 3 and x minus 1 is greater than or equal to 0. I need a positive answer. That's the meaning of greater than this. So if I pick 0, 0 plus 3 and 0 minus 1 is it greater than 0? So now this and this is giving me a positive and this is giving me negative. Positive, negative is negative. So I'm having negative here. Okay, don't forget that the answer we need is just a positive answer because greater than 0 means positive. Okay, so the next thing I'm checking is what? Any number that is greater than, because I'm going like this now. Okay, you go like this, you go like this, then you go in between like this. So any number that is greater than 1, let's pick a number. 2 is greater than 1, so let me pick 2. If I say x plus 3, okay, into x minus 1 is greater than or equal to 0. So if I pick 2, I'll say 2 plus 3, okay, and the 2 minus 1 is it greater than or equal to 0? This and this is 5, and this is what? 1. So this is positive, positive, which is giving me a positive answer. So any part that gives you positive is your result because I need a positive answer. So my answer is now the one moving like this, and we can never get to negative infinity. So we'll use open bracket of negative infinity, comma, minus 3. Okay, minus 3. But I'm going to use a closed bracket for minus 3 because of that equal to. If there is no equal to here, I'll use an open bracket union. I'll unite it with this side gave us positive. So I'm using a closed bracket of 1 and what? Infinity. All right. So why did I use a closed bracket here? Is because don't forget you are moving like this. So you are starting from here and moving like this. That's why I started from 1 and moving to infinity. Here is you started from this and you are moving like this. That's why the minus 3 is here, moving like this. You get it now. So I'm using this closed because of this equality. So this is the answer to this question. So let's move to the next question. Question number 145. So for question number 145, question number 145. Question number 145 said the set of integers that satisfies that satisfies absolute value of n minus 2 is less than 1 is dash. Okay, solution. Now what do we do? Whenever you see absolute value, have the absolute value of n minus 2, okay, is less than 1. The absolute value of n minus 2 is less than 1. So what do you do? To remove absolute value, put the negative of this man. So I'm going to have minus 1 is less than n minus 2, which is less than 1. So what do we have now? This one, this minus 2 can go here. So I have what? Minus 1 plus 2 is less than n, which is less than anything you do to the left hand side, do to the right hand side. So 1 plus 2. So what do I have now? Minus 1, okay, sorry, 1 is less than n, which is less than 3. Okay, is this a correct statement? Let's check. Okay, they say that 1 is less than uh, 1 is less than n. Okay, give me a number that is less than 1. 1 is less than 2. Okay, is 2 less than 3? Yes, it's a correct statement. So we now say that n is an element of an open set of 1 comma 3. Okay, that is how to do that. So this is a correct statement. You say that I'm using open set because there is no equality. So this is the answer to this particular question. All right, so let's move to the next question. Question number 146. Question number 146. And question number 146 said we should solve the absolute value of t minus 5, okay, is greater than 2. Solution. Now what do you do? This is the absolute value of t minus 5, okay, is greater than 2. Now to remove absolute value, we do the negative of this. So minus 2 is greater than t minus 5, okay, which is greater than 2. So what do we have? This one can move here, this one move here. So I have that minus 2 plus 5, okay, is greater than t, which is greater than 2 plus 5. So what do we have now? This and this is going to give me 3 is greater than t, which is greater than 8. Is this a correct statement? Can we say that 3 is greater than t? Okay, and then t is greater than 8. If 3 is greater than t, it means that t is 2. Is 2 greater than 8? No, it's not a correct statement. So in this case, what you do is to solve it differently. To solve it differently. What do I mean solving it differently? Immediately you get this type of thing. Solve it differently, like minus 2 is greater than t minus. In fact, anytime you have greater than, you need to solve it differently. So solve this side different, solve this side different. So I have t minus 5 is greater than 2, right? So what do we have now? Take this side to this. I have minus 2 is greater than minus 2 plus 5, okay, is greater than t, and then I have that t is greater than 2 plus 5. So here and here is giving me 3 is greater than t, and here is telling me that t is greater than what? 8. So here it says that what? T is greater than 3 is greater than t, means that t is less than 3. Okay, so now in this case, what do you do to combine them? To combine them now is to say that if t is less than 3, it means that it is what? That it is from minus infinity to that 3. Okay, anything that is from 3 down to negative infinity. Now if t is greater than 8, means from 8 to positive infinity. So you unite them. So the answer to this is now minus 8 comma 3 union 8 comma infinity, like this. Minus infinity comma 3 union 8 comma infinity. All right, so that is that. Any mistake somewhere? Okay, sorry, this and this is not 8 but 7. So that's the sorry, this is 7. So this is 7, and finally this is 7. So the answer is what? Let me check. The answer is option minus 3 comma 3 union this. Option A is very, very correct. All right, so let's move to 147. Question number 147. Question number 147. Question number 147 says that if I have that minus 1 over 2 is less than minus 3x, okay, minus 2, which is less than or equal to 1 over 2. Okay, now what do you do in this case? Let's do the same thing here. So I have minus 1 over 2 minus 1 over 2. This one moving here, I'm going to have plus 2 is less than, okay, or let me just separate them and solve. I can decide to separate them and solve. Okay, let me separate them. If you decide to separate them, separating them, I have minus 1 over 2 is less than minus 3x minus 2, comma. Then minus 3x minus 2 is less than or equal to half. So what do we have here? This one moving here. Minus 1 over 2 plus 2 is less than minus 3x. And here minus 3x is less than or equal to 1 over 2 plus 2. So this time this is 4. Then minus 1 plus 4 will give you 3. So I have 3 over 2 is less than minus 3x. Okay. Then minus 3x is less than or equal to 4 or 5. So I have 5 over 2. Now dividing everybody by negative. Anytime you divide by negative, the sign must change. So I'm going to have that what? Minus 3 over, we are dividing by this, over 6. Okay. Is greater than x. If this minus 3 is coming down here, it will become 6. But because I'm going with minus, that's why I change it from less than to greater than. So here is now what? X. If I'm doing cross multiply, this minus 3 will go down here. So it will now be greater than or equal to what? 5 over 6. So I'm having 1 here and 3 here. So I have that x, the arrow is pointing to x. So x is less than minus 1 over 6. And here x is greater than or equal to 5 over 6. Now, if x is less than this, can it be greater than this? No. So we have that this is what? From negative infinity to that minus 1 over 6. You close like this. But this one is what? From 5 over 6. I'm using this type of bracket because of equal to what? Positive infinity. You unite them. So that is the answer to this particular question. So we move to the next question. Okay. Or let me check something. Anyways, because the answer here is not familiar. Okay, the answer is not familiar. So let us solve it without separating and see what we are going to get. Let's solve without separating. I'm going to have minus 1 over 2 is less than minus 3x minus 2, which is less than or equal to 1 over 2. Okay, so without separating, I have minus 1 over 2 plus 2 is less than minus 3x, which is less than or equal to 1 over 2 plus 2. So here is giving me 3 over 2 is less than minus 3x, which is less than or equal to 5 over 2. Okay, dividing everybody by minus 3, I'm going to have minus 3 over 6, right, is greater than x, which is greater than or equal to minus 5 over 6. Okay, yes, this is how it's supposed to be. So what do I have now? What do I have? Let me start from this side. So it means that minus 5 over 6. Okay, that's where I made a mistake. I ignored the minus in the other one. So that's the only mistake there. Okay, and even the mistake, the minus was there, then the statement would have been a correct one. So minus 5 over 6 is less than or equal to, because it's pointing this man, is less than or equal to x, which is less than minus 3 over 6. So minus 3 over 3, 6 is same as 1 over 1 over 2. Okay, so now minus 5 over 6 is less than this, which is less than this. So my answer is now that what? X is an element of a closed set of minus 5 over 6 comma minus 1 over 2 open set. So that is the answer to that question. So let's check if it's here. Yes, option A is very, very correct. So this is what you're supposed to do. So question number 148. Question number 148. Question number 148 said that 148 said the solution of 3x plus 3 is greater than or equal to 4x plus 12. Okay, is one of these. Is one of these. So let us solve this solution. So what do? We have that 3x plus 3 is greater than or equal to 4x plus 12. So let me collect like terms. I'm going to have that 3x minus 4x is greater than or equal to 12 minus 3. So this and this is giving minus x is greater than or equal to this 2 is giving me 9, right? 9. So to take minus to the other side, the inequality will change. So x will now be less than or equal to minus 9. So therefore, x is an element of an open set of negative infinity, comma, minus 9. You close. So that is the solution to that. Yes, option D is very, very correct. So let's go to the next question. Question number 149. Question number 149. Okay. And question number 149 said solve the absolute value of t minus 5 is less than 2. Okay. Solution. I thought that if you're using less than, no need to separate. So I have that what? The absolute value of t minus 5 is less than 2, shows that minus 2 is less than t minus 5, which is less than 2. Collect items, I have minus 2 plus 5 is less than t, which is less than 2 plus 5. So what do you have? Minus 3 is less than t, which is less than what? 7. Is a correct statement. Minus 2 is less than, so we have that t is an element of an open set of minus 3 and 7. So why did I use an open set? Because there is no equality sign. So that is the answer to this. Very, very simple. So we move to question number 150. Question number 150. And question number 150 said, okay, there is no 150 but 151. So question number 151 said we should solve the inequality. Solve the inequality. Question number 151. Solve the inequality x squared minus 2x minus 3 is less than or equal to 0. Okay. Solution. So I have, they gave me x squared minus 2x minus 3 is less than or equal to 0. So if I factorize, I'm going to have x squared minus 3x plus x, right, minus 3 is less than or equal to 0. So x into x minus 3, x minus 3 and plus 1 is less than or equal to 0. So I'm having x minus 3 and x plus 1 is less than or equal to 0. Now, the critical point here, in quadratic inequality, we need critical point. In critical point here is what? X minus 3 is equal to 0 to show that x is equal to 3. And x plus 1 is equal to 0 to show that x is equal to minus 1. So the two critical points I have is what? Minus 1 and 3. Don't forget that 0 is in the middle here. So the 3 point I'm testing is, I'm testing from here moving like this, from here moving like this. In fact, let me shade it to show that there is equal to. Then I'm testing inside here. Okay, so let us test the first one. Give me any number that is less than minus 1. Minus 2 is less than minus 1. So I have that x minus 3 and x plus 1, okay, is less than or equal to 0. So the answer I need is negative. Less than means negative. So if I use minus 2, I'll say minus 2 minus 3 and minus 2 plus 1. So this 2 is giving me minus 5 multiplying by minus 1. Am I getting negative? No. I got a positive answer this side. Okay. Let me check in between these two. In between these two is 0. So if I check 0, s minus 3 and s plus 1, okay, is let's check if I'm going to get anything negative. So 0. So 0 minus 3 and 0 plus 1. This 2 is giving me minus 3 and this 2 is giving me 1. So I'm getting a negative answer here. I have negative here. All right. So now any number that is greater than 3 is 4, for instance. So I have x minus 3 and x plus 1. Okay. So I have that 4. 4 minus 3 and 4 plus 1. So this 2 is giving me 1, okay, and 5. The both of them is giving me a positive answer. So the only answer that is correct is in between these two things. So you say that what? That x is an element of a closed set of from minus 1 to 3. Okay, that is just in between this and this. Why did I use a closed set? Because of the equality sign. So that is the answer to this particular question. So we move to the next question. We'll move to the next question. Question number 152. Question number 152. Okay, there's no 152 but 153. Question number 153 said solve x squared minus 1 all over x squared minus 3x plus 2 is less than or equal to 0. Now what do? we solve. Solution, this is very very simple. So just say x squared minus 1 all over x squared minus 3x plus 2 is less than or equal to 0. Now if I factorize this place, I'm going to have x plus 1 and x minus 1, because this is difference of two squares. But if I factorize here, I'm going to have let me factorize it here, x squared minus 3x plus 2, okay, which is s squared minus 2x minus x plus 2. So I'm going to have x minus 2 x here, x minus 2 minus 1 here. So I'm having x minus 2 and x minus 1. Okay, so the factorization of this is x minus 2 and x minus 1. They say it's less than or equal to 0. Now if this take care of this, I'm left with x plus 1 over what, x minus 2 is less than or equal to 0. So the two critical points here, is what, s plus 1 is equal to 0. So x is equal to what, minus 1, and s minus 2 is equal to 0 to show that what, x is equal to 2. So the two critical points is minus 1 and 2. So don't forget that we're testing three things. Due to equality sign here, let me shade. I'm testing like this, I'm testing like this, and I'm testing in between them. Okay, so let's check. Let's check. Now give me any number that is less than minus 1. Minus 2 is less than minus 1. So I have x plus 1 all over x minus 2. We need a negative answer. Less than or equal to 0 means a negative answer. So if I check minus 2 plus 1 all over minus 2 minus 2. So minus 2 plus 1 is it less than or equal to 0? Here is giving me minus 1 divided by minus 4. So which is giving me a positive answer, because I'm having 1 over 4. If this take care of this, is positive. So I have that here. I got positive here. Okay. So in between them, 0 is in between them. So let me check for 0. If I check for 0, I'm going to have putting zeros here. 0 plus 1 all over 0 minus 2. Is it less than or equal to 0? So I'm having 1 over minus 2. And 1 over minus 2 is giving me negative. So I have negative here. So finally, let me check for the other side. Any number that is greater than 2 is 3, for instance. So let me say 3 for here. 3 plus 2 all over 3 minus 2. Is it less than or equal to 0? This and this is giving me 5 over 1. And 5 over 1 is positive. So I'm having positive here. So the only answer here that gave me negative is the middle. So you tell them that what? X is an element of a closed set of what? Minus 1 comma 2. You closed. I'm using closed set because of the equality sign that is there. Okay, so you see that inequality is very very simple. Inequality is very very simple. Okay, so the next question, question number number 154. Question number 154 said the set of even integers, the set of even integers that satisfies the absolute value of n minus 1, which is less than 3, is dash. Okay, solution, very simple. So what do we have? The absolute value of n minus 1 is less than 3 shows that what do we have now? Okay, minus 3 is less than n minus 1, which is less than 3. So what do we have? Minus 3 plus 1 is less than n, which is less than 3 plus 1. So I'm having that what? Minus 2 is less than n, which is less than 4. So therefore n is an element of what? Sorry, an open set. Is an element of an open set of minus 3, sorry, from minus 2 comma 4. I use open set because I'm having what am I saying? I'm having less than here. There is no equality sign, but they say we should get the even integers. So the even integers, so n is an element of a set of an even integer from minus 2 to this is what? Minus 1 is not even, is 0 even? Find out by yourself if 0 is even. So I'm having 2 and okay, only 2. You see, only 2. So if 0 is an even number, so it will not be 0 and 2. But if not, only 2. Because here, the numbers here is what? Minus 1, 0, 1, 2, 3. Okay, these are the numbers here. So the only even number here, I think 2 is the only even number here. I don't know if 0 is even. So you can check if 0 is even. So if 0 is even, you include 0. You can browse it, find out by yourself if 0 is even. Okay, so the next question. Question number. Okay, sorry. In that question number, in that question number 145, where I got that they gave n minus 2 is less than 1, which we got that minus 1 is less than n minus 2, which is less than 1. So I'm having that minus 1 plus 2 is less than n, which is less than 1 plus 2. So I'm having 1 is less than n, which is less than 3. Where I told that n is an element of 1 comma 3, right? So that's what we got. So but what they told us there is we should get the integers. So from 1 and 3, the numbers there. So n is an element of a set of 1 and 3. The integers there is what? 1, 2, and only 2. These are the only integers there. So the answer is this. The last answer is this. From here, you now write that the last answer is this because they say we should get the integers. So integers are just whole numbers. But this is not just whole number. This is any number that is from 1 to 3. At even 1.1 is there and the rest. So but they said integers alone. So the answer there is what? Is just 2. So the 2 is the only integers that will satisfy that particular equation. So I just remembered it now. So the next question is question number 156. 156 said that we should determine determine the range of values of x. Determine the range of values of x for which x squared plus x minus 2 all over x squared plus 4 is greater than 1 over 2. All right. Now solution. Just greater than, right? No equal to. Okay. Now solution. If it is equality here, we do cross multiply. But in inequality, we don't do cross multiply. So we have that what? X squared plus x minus 2 all over x squared plus 4 is greater than 1 over 2. So we need to bring this to this side to have x squared plus x minus 2 all over x squared plus 4 minus 1 over 2 is greater than 0. So we need to find the LCM. The LCM here is what? 2 into x squared plus 4, right? When these two divide, this is remaining to 2 times these people. I have 2 into x squared plus x minus 2 minus when this divide by this is 1 is this time this I'm having minus 1 into x squared plus 4. Okay, everything is greater than 0. So finally I'm having this time this is what? 2x squared plus 2x minus 4 minus x squared minus 4 all over 2x squared plus 8 is greater than 0. So what do we have now? So we are going to have that this and this is giving me x squared. So x squared plus 2x minus 4, okay, all over 2x squared plus 8 is greater than 0. Okay, so at this point we need the critical point. So let us factorize this man to get the critical point. If you factorize x squared minus 2x minus 4, I'm going to have x squared plus 2x minus 4 is greater than 0. So I'm having x squared. How did I get 4? Okay, sorry, minus 8. Minus 4 minus 4 is minus 8. Sorry, minus 8. So I'm having minus 8 here. So minus 8 is what? Plus 4x minus 2x minus 8 is greater than, sorry, is equal to 0. I want to get the critical points. Or I'm just factorizing. So I have x into x plus 4, minus 2. So I have x plus 4 and x minus 2. Okay, here I'm having x plus 4 and x minus 2 all over 2x squared plus 8 is greater than 0. Now, there is nothing that you put here in the denominator that will make it 0. So there's no critical point for the denominator. Let us check. So I'm having x squared, 2x squared plus 8 is equal to 0, right? So I'm having, so the critical point here is what? Is minus 4 and 2. Don't forget. But here, there's no critical point. What? 2s squared is equal to minus 8. So I have that what? S squared is equal to minus 8 divided by 2. So s squared is equal to minus 4. And x is now what? The square root of minus 4. And square root of a negative number is a complex number. So there is nothing that you put in this equation to make it 0. It's not possible. So the only critical point I have is what? Minus 4 and 2. So the only critical point I have is minus 4 and 2. Because that's the only thing we can put for the numerator to make it 0. In fact, we don't even need a number we can put here to make it 0. Because if you make it 0, it will be undefined. So we don't need any number here to be even 0. So the critical point we are getting is from the numerator. All right? Okay. So now let us check out what will give us a positive number. Greater than 0 means positive. Let's check this side. Give me any number that is greater than that is less than minus 4. Give me a number that is less than minus 4. That is minus 5. So if I put here, I'll be having minus 5 plus 4. Put here, minus 5 plus 4 will give you minus 1. Minus 5 minus this will give you what? What am I saying? Will give you minus 7. The both of them is positive, and the negative of everything here will be positive. I hope you know minus 5 squared is positive. Positive is 25. 25 times this plus this is giving me positive. So I have positive up, positive down, positive, positive is positive. I have positive here. Okay, now in between minus 4 and 2, 0 is in between them. Yes, 0 falls there. So if I put 0 now, if I put 0 here, I'm having 4. If I put 0 here, I'm having minus 2. If I put 0 here, I'm having positive as well. Positive anything. So negative, positive is negative. So I'm getting negative here. So what about this side? For this side, any number that is greater than 2, let me say 3, for instance. So if I put 3 here, 3 plus this is giving me positive 7, right? 3 minus this is giving me positive 1. 3 here is still giving me positive. Positive, positive is positive. Okay? So the solution to this equation say that what? So x is an element of, now, from negative infinity to minus 4, or x is an element of from 2 to positive infinity. So we now have that x is an element of minus infinity comma minus 4 union 2 comma infinity. So that I'm using open bracket because there is no equality sign here. So this is very, very simple. So we move to the next question. Question number 157. 157. Okay. For question number 157, okay, no 157, 159. For question number 159, they say we should solve the absolute value of t minus 3 is greater than 2. Okay, solution. So we have absolute value of t minus 3 is greater than 2, means that minus 2 is greater than t minus 3, which is greater than 2. I told you whenever you have greater than, you're going to solve them differently. So I have minus 2 is greater than t minus 3, and t minus 3 is greater than 2. So what do we have here? Minus 2 plus 3 is greater than t. What do we have here? T is greater than 2 plus 3. So what do I have here is 1 is greater than t, and I have that t is greater than 5. Okay. Now from here means that t is pointing at t, so t is less than 1. The arrow is pointing at t, so if you write t first, let it still be pointing him. So now from here means what? Anything that is less than 1, so which is minus infinity to 1. Anything that is greater than 5, which is what? From 5 to positive infinity. So the answer here, t is an element of negative infinity comma 1 union 5 comma positive infinity. So that is the answer to that. So we move to the next question. Question number 160. Question number 160, which is the last question here. 160 said we should solve the absolute value of t minus 3 is less than 2. I told you for less than, you can just solve this straight, no need to separate. So I have absolute value of t minus 3 is less than 2, shows that minus 2 is less than t minus 3, which is less than 2. Take this side, minus 2 plus 3 is less than t, which is less than 2 plus 3. So this and this is giving me positive 1 is less than t, which is less than positive 5. So t is an element of open set of 1 comma 5. So thank you very much for watching. Please like, share and subscribe. Bye bye.